Okay. So these are all the problems we are going to discuss. So before we go to the problems, can we please recall the formulas?
Yes.
Okay. First, the first formula, what is the speed? How to measure the speed? V, which is equal to frequency multiplied by lambda. What is the frequency? Frequency which is
1
equal
over
to,
pi.
very good. And then time period which is equal to
1
1
over
over
frequency.
frequency. And then relation connecting angular frequency and the linear frequency. Omega which is
2
equal to
pi over
Pi
t.
f.
2 pi. Oh my God. I don't know. Something happened to my pen. Still I have this issue. So omega which is equal to 2
2
pi
pi.
f or 2
2
pi
pi
over t. Very good. And then what is wave equation? The displacement of the wave equation of y of x comma t, which is equal to amplitude
Amplitude.
multiplied by sine wave
Kx.
kx minus omega
Kx
t.
minus omega t.
Very good. And what is our angular wave number? Angular wave number k, which is equal to
1 over lambda.
2 pi over lambda. Not 1 over lambda. 2 pi over lambda. Am I right?
Yes, sure.
Yes.
My dear, when you write the formula, you should be very, very careful. Huh? That means k, which is equal to 2 pi over lambda. And then what is the formula for speed of the wave? How to measure the wave speed in the string? V, which is equal to square root of t over
Tension over
linear density. What is linear density? Linear density which is equal to mass over length. Am I right?
yes.
And then the general formula for finding the lambda n, which is equal to 2l
So all
over
over n.
n, where n which is equal to 1, 2, 3 up to so on. Okay. And then with the help of this lambda n, we can easily find the frequency number of frequency which is equal to nv over 2l.
So
Is there any formula is missing here? I think we wrote everything. Am I right?
speed.
Power of the wave, power p, which is equal to linear density, speed, ym square, omega square
Omega square.
over 2. Is there any other formula is missing?
Speed, Mr. I think
We write two formula. One is the speed of the general formula for the speed, and another one is for the general form, the equation, the speed of the wave on the string. Am I right?
Yes, sure.
I think we wrote everything. Inshallah, if anything missing, when we are about to solve the problems, by the time we will see. Okay.
Okay.
Okay. So these are all the 5 problems. 5 problems we are going to discuss. Let's we go from the first one. What is given in the first question? My dear, please read the question at least twice a time. It's very, very important. The equation of the transverse wave. That means they give the information about the transverse wave. What is our transverse wave, my dear? Your transverse wave will be like this. Am I right? Am I right?
Yes.
So the transverse wave is given in terms of wave equation format. So they give the wave equation format. What is our wave equation? This equation, could you please tell? Given y, which is equal to 2 millimeter multiplied by sine of 15 per meter multiplied by x minus 900. Oh, I have to replace the needle, I think so. $900 per second multiplied by t is given. This is the wave equation. And what else is given? The linear density value is given. What is linear density? Mu. Am I right? So the mu value is given as 4.17 gram per meter. So when you are about to do these things, you have to convert this value in terms of kilogram. So if you convert it to kilogram, what you will get, my dear? 4.17 multiplied by 10 to the power of minus 3 kilogram per meter. Am I right? Am I
Yes,
right or
you
not?
are.
We converted the gram to kilogram. That's what I just multiply by 110 to the power of minus 3. Now, what are the informations they need? We have to find what is the wave speed. What is wave speed? V. Am I right? So we have to find the value of V, and then what we are going to find? We are going to find what should be the value of the tension on the string. So, my dear, listen carefully. In the question, they give the wave equation and then they give the linear density. Only two informations are given. So now what we have to do, with the help of this wave equation, we can find some parameters. Am I right? Am I right or not? Could you please recall what is your wave equation? Y, which is equal to ym
Amplitude.
sine of
K.
y, which is equal to ym sine of
K.
kx minus omega t. Am I right?
T.
Yes.
Yes, you are.
My dear, now you can see I am going to compare each and every term. So this is our y term. Am I right?
Yes.
Yes.
Am I right? What is our amplitude? This is our amplitude. Am I right?
Yes, 2.
What is our k? This is our k. Am I right?
Yes.
Yes.
And what is our omega? Our omega is 900. Am I right or not?
Yes, doctor.
Yes.
So with the help of this information, we are going to find the value of the speed and we are going to find the tension. Now what I am going to do, I am going to compare the two concepts. First I am going with k. What is k? The k is our angular wave number. Am I right? So what is the formula for angular wave number, my dear? This is the formula. Am I right?
Yes.
So I'm going to write here when I compare the equation. So I'm going to write this is my equation 1. This is my equation 2. So from equation 1 and 2, my k value is equal to 15. Am I right?
Yeah, what about the unit?
This is unit. Don't worry. We will write the unit later. This is the unit for the k.
Okay.
Okay. So my k value, which is equal to 15. And here my omega value, which is equal to 900. Am I right?
Yes.
Yes.
Okay, what is K? K formula we already know. What is that? 2 pi
2 pi
over
2 pi
lambda, which is equal to 15. Am I right?
Yes.
Yes.
And what is our omega? Omega, which is equal to 2
pi
f. Am I right?
multiply.
Oh,
Yes.
Allahu. I erased everything. Sorry, my dear. I think because of the problem in my pen, everything is gone. Okay, I can just write speed. Y 2 millimeter sine of 15 per meter multiplied by x minus 900 per. Today I think my pen makes lot of issue. 900 per second t. So if I just write the wave equation, this is ym sine of kx minus omega t. Okay, what is our k? Our k, which is equal to 15, and my omega, which is equal to, what are you? My dear, I'm extremely sorry, because the problem is
No
in my
problem.
pens.
Yes, sir, no problem.
No problem.
I have to replace the needle, my dear. Actually, today I forget. Really, I'm not feel comfortable. Sorry. So K, which is equal to 15, and omega, which is equal to 900. What is K? 2 pi over lambda, which is equal to 15. What is omega? Omega, which is equal to
Pi over
2 pi f,
over
which is equal to 900. Am I right? We can write f. No need to go for time period, because time period information no need here. Clear?
okay.
Okay. Now,
Yes.
with the help of this, we can easily find the lambda. Am I right? Because what is given in the first question, we are going to find the v value. What is the formula for speed? The speed, which is equal to frequency multiplied by lambda. Am I right?
Yes, you are.
Yes.
So from this, I am going to find the value of lambda. Can you please rearrange this equation? Therefore, my lambda, which is equal to 2 pi
15
over
over
15.
over 15.
Over 15.
Am I right?
Yes.
2 pi
Yes.
over 15. Am I right? Okay. Likewise, here we are going to find the
900,
frequency. There, what my dear?
900 over 2 pi.
900. Yes, frequency, which is equal to, very good, 900 over 2 pi. Am I right? Now we have the information of lambda and frequency. So I am going to find the answer for the first question. Speed, which is equal to frequency multiplied by lambda. My frequency value, what is my frequency value? 900 over 2 pi multiplied by, what is my lambda value?
Will be
2
cancelled.
pi. Yes, that's what I write like this. So I can cancel this 2 pi with 2 pi. Therefore, 900 over 15, which is equal to 60. Am I right?
Yes.
Clear?
Clear.
This will be the answer for the first question. Is it clear?
Can you repeat it,
We have-
Doctor?
You mean the first question?
Doctor, what
Yes,
about
my dear, listen carefully.
m
Yes.
or minus 1?
My dear, m minus 1 is the unit for the k, because there is no unit for the pi. For the lambda should be measured in terms of meter. So what is the unit for this lambda? The unit for this lambda is 1 over meter. Am I right?
Yes.
And what is the unit for this? This is nothing but frequency. 1 over second is the unit. Am I right or not? You already studied this formula in chapter number 15.
Okay.
Clear? Clear?
Yes.
So with the help of the wave equation, we find the value of lambda and we find the value of frequency. Once you find this lambda and frequency, we can easily substitute the value in the given formula. We will get the answer. Clear?
Yes,
Clear.
Doctor.
Okay.
Doctor,
Okay. Yes.
what
Yes.
about the first unit that we talk about in the first equation?
This one. This one.
Yes.
My dear,
15.
yes, actually, listen, my dear, this is the general wave equation. This is the general wave equation. Am I right? They
Yes.
give the wave in terms of equation. That equation is the first one. So now we have to compare the general equation with the given equation. You can see the first one and second one are the first one and the second one are exactly the same. Am I right or not?
Okay.
My dear, could you
I
please
have to see the
okay.
unit.
Okay, could you please, okay, listen, could you please tell me the general equation? Y, which is equal to ym. Am I right?
Yes, you are.
Sine, what is this? K,
Kx.
x. Am I right? What is the unit for K? The unit for K is per meter. Am I right or not? What is the unit for this K?
Meter.
Per meter, not meter, per meter, 1 over meter.
Okay.
Clear? Okay, minus omega, multiply by T. What is the unit for omega?
Uh,
The omega unit is
X over 1 over 8.
S power minus 1. Am I right or not? Am I right or not?
Not radians per second.
It's good.
My dear, both are correct, my dear. If you write S power minus 1 or 1 over second, both are same.
I mean radians per second.
My dear, radian is it's a dimensionless. Radian has no dimension. Even if you write radian, it's meaningless. There is no dimension.
Okay.
دكتور
Yes.
the equation always come with the sign.
Yes. The equation will come with a sign. You can see here. The equation is coming with a sign.
Okay.
Clear? So we compare. What equation is given in the question? Y, which is equal to 2 millimeter sine of the k value is given. What is the k value? The k value is 15x. And what is the omega value? They give the omega value is 900t. Am I right? Am I right or not?
Yes,
Yes.
So by using this general wave equation, we find the lambda and we find the frequency. With the help of this, we easily find the answer for the first question. Clear?
Yes, doctor.
Okay. Now let's go for the second question. What is the second question? We have to find what is the tension on the string. My dear, what is the formula for tension on the string? We have another formula, V, which is equal to square root of mu
T over
mu over
mu over
sorry,
T.
T.
T
over
over
mu.
mu. Sorry. So T over mu. So I have to write this rule here. I'm going to delete this. Today I am not feel comfortable. I'm sorry for the inconvenience. Okay, T over mu. Now in the question they already give the value of mu. Am I right? What is the value of mu? 4.17 gram per meter. Am I right?
Yes.
4.17 gram per meter. If you convert this gram in terms of kilogram, so what you will get? You will get this as 4.17 multiplied by 10 to the power of minus 3 kilogram per meter. Okay. Now we are going to find the value of T. So before we substitute the value, I have to take the square on both sides. So if you take the square on the left hand side, your V becomes V square. Am I right?
Yes. Doctor.
If you square this, what will happen? Square root will gone. So you will get T over mu. Am I right?
Yes. Here.
Yes.
So now if you rearrange this equation in terms of T, you will get V square mu, which is equal to T. Am I right?
Yes.
Yes.
So now we directly substitute the value because the value of the V we already find in the first question as 60 meter per second. Am I right?
Yes.
So I'm going to directly substitute the value. Therefore, T, which is equal to 60 square multiplied by what is the value of mu? It is already given in the question as 4.17 multiplied by 10 to the power of minus 3. When you just multiply, you will get the value of the tension as 15 and the unit is Newton. Clear?
Yes, very clear.
My
Yes,
dear,
good.
you have to do one thing. When you are about to prepare for the exam or when you are about to go for revising this chapter, please check the answer. Understand? Maybe sometimes I may made the mistake in the answer calculation, but the procedure what I followed is exactly correct. Okay? But mostly 99% my answer is correct. Okay?
Yes, doctor.
Okay.
I have a
doctor.
question, doctor.
Yes, my dear. Ask your question.
We know that tension is equal 1 over F. Why we didn't use it immediately?
Tension which is equal to what?
Tension is equal 1 over F.
My dear, that is time period, not tension. That is time period. Don't get confused.
Oh, okay.
Don't get confused about this T and this T, my dear. This T is the tension. Okay? This is tension and this T is
Time period.
time. Clear?
Yes, yes.
Ah. Is it clear? Do you have any doubt in the first question?
Everything is clear.
Okay, perfect. So we can jump to the second question. My dear, answer is here. Inshallah, I will upload the slides after the lecture. Okay. So answer is here, but anyhow, you can take the practice. Let's come for the second question. Okay, we will deal the second question at the last because it is some theoretical question. I will deal this question last. First of all, we can go for the numerical type question. Could you please read the question? What is given here? The wave has the angular frequency. What is angular frequency, my dear? Omega. Am I right?
Yes.
Am I right or not?
Yes, yes.
Yes, you
Yes.
are.
So I can write what is given. My angular frequency omega is given as 110 radian per second. My dear, radian is the dimensionless. So even you can write 1/second here. Okay. So and then the wavelength is given. What is wavelength? Lambda. Am I right? Lambda is 1.5 meter. And what they need, we have to find the angular wave number. What is angular wave number?
Okay.
Angular wave number is K. Very good. And then in B question, you have to find the speed. Am I right or not? So now, my dear, we know the formula for the angular wave number. What is the formula for angular wave number?
2 pi over
2 pi over lambda.
2 pi over lambda. Very good. So I'm going to use that formula here. So this is just a direct question and very easiest question. So 2 pi over lambda. So lambda is already given. So I can easily find the value as 2 pi divided by, what is the lambda value? 1.5. When you just work out with your calculator, you will get the answer as 4.19 radian per meter. Because the unit for the lambda is meter, so you will get the answer as K, which is equal to radian per meter or 1/meter. Clear? Clear?
Yes.
Clear, yes.
Okay. Now, when you come for the second question, we have to find the speed. My dear, speed, what is the formula? The formula for the speed is frequency multiplied by lambda. Am I right?
Yes.
Yes.
So, if you want to find the answer for this, first of all, we have to find the value for the frequency. Am I right?
Yes.
Yes.
And we have
So
omega.
we know the angular frequency omega, which is equal to 2 pi f. Am I right? So from this, I can easily
Right.
find the value of f. Therefore, f, which is equal to omega divided by 2 pi. Am I right?
Yes, you are.
Omega is already given in the question. So if you substitute the value of the omega, this becomes 110 divided by 2 pi. So you will get the answer for the frequency as 17.5 per second or 1/second. 17.5 per second you will get. Now, when you find this, once you find this value of f, I can directly find the answer for the b, because we know v, which is equal to frequency by frequency multiplied by lambda. My frequency, what is my frequency? My frequency is given here. My lambda is given here. Am I right? So I can directly find the answer v, which is equal to 17.5 multiplied by
1.5.
1.5. So your answer will be 26.25 meter per second. So this will be the answer for B part.
Doctor,
Clear? Yes.
the wavelength, it's mean lambda.
Wavelength means lambda. Frequency means F. Angular frequency means omega. Keep this information. Okay?
Teacher,
Okay.
Yes, my dear.
this question is not with us.
Not with us means what?
You say just 4, 11, 35, 45, and 52.
Really? Oh,
Yeah.
33 is here. My dear, 33 is here. My dear, I skipped 11th question. Don't get confused. I skipped the 11th question. I'm going to teach 11th question last.
Okay.
Because 11th question still I didn't finish. I'm directly jumped to 33rd question. Okay?
Doctor, here a frequency unit is to power minus 1.
Yes, or you can write hertz. Both are correct.
Okay.
If you write hertz, I will give full mark. If you write 1/second, I will give full mark. If you write s power minus 1, I will give full mark. So don't worry, everything is correct. Clear?
Clear, yes,
Clear.
Doctor.
Shall I go to the third question?
Yes, yes.
Okay. So our third question, it's very, very easiest question, but you should know what is given in the question. That's very, very, very important, my dear. Please read the question very carefully. What is given here? What are the lowest frequency? What are the second lowest frequency? What are the third lowest frequency? What is the lowest frequency? When frequency which is equal to 1, then that is considered as the lowest frequency. Am I right? What is the
Doctor,
general formula for, my dear, what is the general formula from the frequency? I think I
no,
can just
the-
open the first. What is the general formula for the frequency? This is the general formula. Am I right?
Yes.
Yes.
Am I right? Fn, which is equal to Nv over 2L. What is N? Our N, which is equal to 1,
1.
2, 3,
Yes.
4, so on. Am I right? So, what is the first frequency means? First lowest frequency means when N is equal to 1, that is considered as first lowest frequency. Clear? What is the value of 1? So, this is your first lowest frequency. What is your second lowest frequency? When F is equal to 2. This is your second lowest frequency. What is your third lowest frequency? If F is equal to 3, what is the third lowest frequency? Understand? Clear?
Yes, Doctor.
So we can directly use the rule, but before that, we have to read what is given in the question. So we are going to find what is the value of F1, what is the value of F2, what is the value of F3. So these three informations we are going to find, but rest of the things is given. Let's we just continue to read the question. What is given here? And then the standing waves on the wire, and the wire length is given. What is the length of the wire? The length of the wire is given as 10 meter. And the mass of the wire is given. What is the mass of the wire? What is the mass of the wire?
100 gram.
100 gram, or 100 multiplied by 10 to the power of minus 3 kilogram. Clear?
Very good.
And then you give some tension to the string. How much tensions you gave? You gave the tension as 275 Newton. My dear, now this question is very, very easiest question. You can directly use the basic formula for the frequency. What is our basic formula for the frequency, my dear? You can just recall the basic formula. My basic formula, Fn, which is equal to Np over 2L. Am I right?
Doctor,
Yes.
what's 10 meter?
What?
What's 10 meter?
I couldn't get you what you are saying.
10 meter, 10 meter, 10 meter, 10 meter.
My dear, listen carefully. You have a string, and then
tension or
this
what?
string, you attach some mass. By that, you produce some strength, some tension on the string. What is the total length of the string? The total length of the string is 10 meter. And then what is the mass of the string? The mass of the string is 100 gram. Clear?
Yeah, okay.
Okay, now this is the basic formula for finding the frequency. Am I right? We can directly substitute the value here. So what is your first lowest frequency? When n is equal to 1, that is your first lowest frequency. Am I right?
Yeah.
So I can write for the first question, I am going to substitute when n is equal to 1. So what is your answer? F1, which is equal to n. What is your n? So n, I am going to write as it is. What is the formula for speed of the wave on the string? The speed of the wave on the string, v, which is equal to
tension.
so v, which is equal to square root of t over mu. Am I right?
Yes.
Divided by 2L. Am I right?
Sure. Yes.
And what is mu? We know mu, which is equal to mass over length. Am I right? So F1, which is equal to n square root of t over m over L. Am I right? Divided by 2L. Am I right?
Yep.
So if you just rewrite this equation, F1, which is equal to n square root of t L over mass divided by 2L. Am I right?
Yes.
Now you can see everything you have. What is the value of N?
1.
1.
What is the value of tension? It is already given in the question.
Yes,
275.
275.
Length of the string is given as 10 meter. Mass of the wire is given as 100 gram, and length of the string is given as 10 meter. When you substitute, you will get the answer for the first question. Am I right?
Yes.
Yes.
Okay. Likewise, B. What you are going to do? You are going to substitute N is equal to?
N2 equal to 2.
So my dear, if you want to make your life easy, I can write my F2, which is equal to 2 multiplied by F1. Am I right?
Yes, you are.
So directly you can find the answer. No need to go for the steps again. Am I right or not?
And also,
Right.
And then third part, F3, which is equal to 3 times of F1. Am I right?
yes, you are.
So directly, once you find the value of F1, you can directly multiply by 2. You will get the answer for the second question. If you want to know what is the third lowest frequency, you can directly multiply third with F1. You will get the answer. Or else, if you want to work out like this, no problem. Go ahead, but do it very carefully. Clear?
Okay. Clear, yes.
Clear.
Now,
My dear, even if you go for the second part like this, no problem. You will get the correct answer. But don't waste your time. Because here N is 1, 2, 3. So first lowest frequency, N is equal to 1. Second lowest frequency, N is equal to 2. Third lowest frequency, N is equal to 3. So directly, once you find F1, multiply by 2, you will get the answer for the B. Once you get the F1, multiply by 3, you will get the answer for the third question. Clear?
clear, yes.
So that informations are given here, but anyhow, you can just work out by yourself. Understand?
Yes.
Yes.
The last question. It's very, very important question. In some exams, we ask this question. So please, my dear, listen carefully. Again and again, we are going to play with the same rule. But please read what is given. That's very, very important.
Victor, this
Clear?
is the last one.
My dear, after I finish, I can finish I have to finish the 11th question also.
Okay.
Okay, after that, the class is over. Okay. Okay. Can you please read the question? What is given in the question? A string along which waves can travel 2.7 meter long. So how much distance the wave travel along the string? What is the string length?
2.7.
That means they clearly mention what is the string length. So the length of the string they clearly mention. What is the value? L, which is equal to 2.7 meter. Clear?
Yes. And also the mass.
And also the mass is given. So, okay. First of all, I have to replace this pen. Then only I feel more comfortable. Okay. So the length of the wire is given as 2.7 meter, and the mass of the string is also given, the M, which is equal to 130 gram. So if you convert it to kilogram, it becomes
Multiply by
multiply by
10 to the power
130
-3.
multiplied by 10 to the power of -3 kilogram. Clear? And then
Yes.
the tension produced in the skin, the string is given T, which is equal to 36 Newton. 36 Newton you applied for that. And then you have to find what must be the frequency. So you have to find what is the frequency. So you have to find the frequency, and also the amplitude of the wave is given. What is the amplitude? Ym value. Am I right?
Yes.
7.70 millimeter. If you convert this millimeter to meter, you will get
7 multiplied by 7 multiply
Multiply
by
by
10
what?
to power -2.
Minus
my
2.
dear,
Minus.
my dear, 10 to the power of
No, no,
-3.
Yeah, minus.
-3, yes.
Because when you convert this millimeter to meter, 10 to the power of -3. When you convert the the centimeter to meter, it becomes 10 to the power of -2. So don't get confused. Okay. So and also the power of the wave is given. What is the power? P value. Am I right? What is the value? 170 watt.
170.
So see how many values are given. Length of the string is given. Mass of the string is given. Tension produced on the screen is given. Amplitude of the wave is given. And then power of the wave is given. With the help of all these things, what you have to find? You have to find the frequency. So they clearly mention what must be the frequency. So you have to find what should be the frequency. Yeah. Clear?
Yes.
Yes.
So
Yes.
if you just see the given, the power is given. Am I right? The power value is given as 170 watts. So we have the formula for the power of the wave. Am I right? So what is the power of the wave formula, my dear? The power of the wave formula is given as P, which is equal to mu V
V
amplitude
I
square omega
Omega
square
Square.
divided by 2. Am I right?
Yes.
Am I right? And also, my dear, we have to equate this term with angular frequency. Can you please recall what is the formula for angular frequency? Angular frequency omega, which is equal to
2 by frequency.
2 pi f. Am I right?
Yes.
Am I right? So okay. Now what I am going to do? I am going to rearrange this equation in terms of omega square. Can you please rearrange this equation in terms of omega square? If you rearrange, what you will get? Omega square, which
2
is equal
power
to 2 multiplied
2
by power divided by mu v
V.
ym square. Am I right?
Yes, you are.
And also, I am going to change this equation in terms of omega square. So what you will get? Omega square, which is equal to 4 pi square frequency square. Am I right?
Yes, you are.
So now you can see this is my first equation. This is my second equation. Am I right? Am I right?
Yes.
Now you can see my left hand side of the equations are omega square. So I can equate these two equations. Am I right? So how I can write? I can write this equation as 4 pi square frequency square, which is equal to 2p divided by mu v. This line is irritating. Mu v ym square. Am I right?
Yes, you
Yes.
are.
So can you please rearrange this equation in terms of frequency square? So what you will get? Therefore, my frequency square, which is equal to what you will get?
2b over mu
2B
v.
over mu V.
So if you rearrange this, if you rearrange correctly, then your problem will be very easy. So I am going to rearrange this. So 2p divided by 4 pi square mu v ym square. Am I right?
Yes.
Now, my dear, we have the waves on the string formula. V is here, so there is no information about the V here. Am I right? So I have to use the equation V is equal to square root of T over mu. Am I right? And what is mu? Mu, which is equal to square root of T L over mass. Am I right? Am I right?
Yes.
Right.
So I'm going to take this, I'm going to substitute here. If you substitute f square, which is equal to 2p divided by 4 pi square mu, and sorry, mu, I can just substitute the formula. What is our formula for the mu?
M
What is the
over L.
formula? So I can directly substitute the formula here. That will be very easy. So 4 pi square mass, and this length will go to the top. Am I right? So I can write L here, right?
Yes, you are.
And then V. What is our V? Our V is square root of TL over mass and Ym square. Clear? Clear?
Yes, doctor.
Now you can see what is given here, and then we are going to find only the frequency. Am I right or not?
Yes, take the square root.
Take the square root on both sides. So if you take the square root on both sides, what you'll get? F, which is equal to square root of 2 PL over 4 pi square multiplied by mass multiplied by square root of TL over mass multiplied by ym square. Now you can see, my dear, all the data we have the information about the power, we have the information about the length of the string, we have the information about the mass of the string, we have the information about the amplitude. Once you substitute, you will get the answer. Am I right? Am I right or not?
Yes.
That's it. So this question is very easy, but you have to think what is given. And also you have to use some concept. So here, what concept we use? I compare the power equation with the angular frequency. So I just squaring the terms in terms of omega square. I compare the equation. I substitute them.
Doctor, why you multiply by mass? And,
Where I multiply by mass?
Yeah.
Where?
4 pi
Which
square.
equation? Where?
The last equation. Here.
Here?
Yeah.
Here?
Yes.
Here? This one?
Yes.
Yep.
My dear, you can see here. Here we have omega, which is equal to 2 pi f. Am I right?
Yes.
Yeah.
When you squaring, this 2 becomes 4. This pi becomes pi square. This f becomes f square. Am I right?
Yeah, I know. I mean, why you multiply by mass here?
Where I multiply by mass already.
You put M,
Okay.
Doctor.
My dear, listen here. What is this? What is this? What is this?
L.
So m will come, L will go to the numerator. Am I right or not?
Yeah.
That's what I write here. Write like this.
Yes.
Clear?
No, I get it.
It's clear?
Yes, clear.
Okay, that's it. So answer is given here, but take a practice. Clear, my dear?
Doctor, the unit.
Unit hertz or 1/second.
1/second.
Clear?
Okay.
Understand?
Yeah.
Okay, now we have to jump to the 11th question. Clear? What is given? My dear, this question is related with you are going to mix two waves. So if you mix two waves, it becomes superposition principle. Am I right? We already studied two superposition principle. Am I right or not?
Yes.
So two identical traveling waves. So that means you have two same type of waves which is moving in the same direction. That means both waves are moving in the same direction, and one wave is out of phase of 0.7 pi radian. That means it is little bit tilted. For example, it should be like this. You can see the diagram. I can just write like this. I have the first wave like this. I have the first wave like this. First of all, I just draw and then explain, my dear. First of all, I will draw and then explain. Okay.
Thank you.
I have the wave, first wave. This is my first wave. Am I right? Whenever I just got this, it's really. Again, this is coming. Oh.
Keep it, Doctor. No problem.
Oh, okay, just because I have to draw another wave on the same thing. That's what it's really not good. Okay, leave it. I lost my patience. Okay, this is my first wave. Okay, and then how many waves are given here, my dear? You can just read the question. Two identical waves. This is my first wave, and you have another wave, and both waves are moving in the same direction. For example, according to this diagram, the wave is moving on the right hand side. What is my second wave? My second wave, I can change the color of the second wave. By that, you will get the idea. So I can change the color as green. Okay. Clear?
Yes.
My dear, you can see here, I have two waves. The first wave is green, the red color. My second wave is green color. Both waves are moving in the same direction, but my second wave, green color, is little bit out of phase. What is the little bit out of phase? That value is given as this much phase difference. My second wave is moving. Clear?
Yes.
If both
I
are
can
moving in the
understand.
same, my dear, listen. I can just draw another diagram and then you will get a clear idea. Okay. I can just draw the another diagram. My dear, what is the difference between these two pictures? Can you please tell me?
The same.
My dear, here my two. My dear, listen. My dear, listen here. Here my two waves are exactly moving on the same phase. Am I right? That's what
Yes.
its crest is exactly matched with the crest. Trough is exactly matched with the trough. Clear?
Yes.
But if you see the first picture, both waves are moving the same direction, but the phase is little bit changes for one wave. Clear?
Yes, clear now.
So how much phase is changed? The phase is changed based on 0.7 pi radian difference. The second wave is moving with the first wave. Clear?
Yes.
Yes.
Yeah.
Okay. Now what I am going to do? I am going to write the wave equation. Can you please recall what is your wave equation? What is wave equation?
The
Sin
Over it.
x minus omega.
Y which is equal to ym sine
Sin k
kx minus omega t. Am I right?
T.
Am I right?
Yes.
Okay, my dear, here we have two waves, so I can write this is my y1. Okay, my first wave is red color, so I write this equation for the red color wave. My second wave is little bit tilted with a phase of 0.5, so I have to write the second wave equation y2, which is equal to ym again sine of kx minus omega t. How much phase difference it is tilted? It is tilted with a phase difference of 0.7 pi. Clear?
Clear, yes.
So the first equation is for the red color, the second equation is for the green color. Clear?
Yes, clear.
Okay, now I am going to find the resultant wave. What is the resultant? By mixing these two waves. So what is the resultant wave, my dear? My resultant wave y, which is equal to y1 plus y2. Am I right?
Yes.
So I am going to add these two. So what you will get, my dear? Y, which is equal to, everything is same. So I can take ym, because the first equation also I have ym, second equation also I have ym. So I take ym as the constant. Okay. So I'm just to take ym outside. So sine of first wave kx minus omega t, and then plus sine of kx minus omega t plus 0.7 pi. Clear?
Yes.
Clear?
You take
Now,
y as a common.
yes, because both equation I have ym, so I take it ym constant, the common term.
Yes.
Clear? Okay. Now, my dear, if you want to make your life easy, I am going to use one trigonometric formula. You already studied, maybe inshallah you will study it later. This formula in trigonometric, we have the formula of trigonometric sine A plus sine B, which is equal to 2 sine a plus b over 2. Oh, again, I don't know something. A plus b over 2 multiplied by cosine of a plus b over 2. Clear? I am going to use this formula for this equation. You can see here also I have sine, here also I have sine. I am going to consider this term as a and this term as b. Clear? I am going to compare this equation. I am going to compare this equation with this equation. So what is the formula for sine a plus sine b? The sine a plus sine b is 2 sine a plus b over 2 multiplied by cosine a plus b over 2. Now you can see here also I have sine some term plus sine some term. So I am going to take this term as a, I am going to take this term as b. Am I right?
Yes.
Now I'm going to use this. I'm going to use this for this part. So if you substitute this formula here, what you will get, my dear? You will get y, which is equal to. Actually, my dear, don't worry. This is the theoretical type of question. In general, in exam, the question, this type of question will not come. So don't excuse your brain. Okay.
Doctor, if I use the general equation, it's okay or not?
General equation. Do you have any other formula for general equation, trigonometry?
No, I mean ym multiply by sine kx minus
omega t.
Yeah, this equation.
Even if you multiply inside, you will get the same term. But I'm going to use this term. That's what I take ym outside.
Oh, it's easier.
Yes. Okay. Now you can see I'm going to substitute this formula here. So what you will get? Y, which is equal to my ym. My dear, I'm going to substitute here. What is this? 2 sine a plus b. What is our a here? What is our a, my dear?
kx minus
Kx minus omega t plus b. What is my b? Plus kx minus omega t plus 0.75 divided by
2.
Am I right?
Yeah.
Multiplied by cosine of a plus b. What is my a? Sorry, this is a minus b. This is a minus b. So cosine of what is our a? Our a term is kx minus omega t minus of b. Minus into plus, minus into minus, plus minus into plus, minus I'm extremely sorry for this pen, my dear. Even I'm not feel comfortable. Okay, so minus into plus, minus divided by 2. Am I right? Am I right?
Yes.
Yes, doctor.
Okay. Now simplify this. If you simplify this, ym 2 sine kx plus kx. So what you will get, my dear? Kx plus
2kx.
Very good. 2 kx minus omega t minus omega t minus 2 omega t plus 0.75 divided by 2. Am I right?
Yes.
Am I right? Okay. Likewise here, cosine of kx plus here minus. So what will happen? This will get cancelled. Am I right?
Yes.
And here minus omega t plus omega t. This will get cancelled. Am I right?
Yes.
So what you will get? Minus of 0.7 pi divided by 2. Am I right?
Yes.
Clear? I can open one
Yes.
more slide. Just a minute, my dear. I can open one more slide because this space is not enough for me. So I can just write the same thing again. So what you will get? Y, which is equal to 2, sorry, y which is equal to ym 2 sine of 2 kx minus 2 omega. Oh, y which is equal to ym 2 sine of 2 kx minus 2 omega t plus 0.7 pi. My dear, I am going to leave as it is, so don't get confused. Huh? I have no energy to erase these things again and again. Divide by 2, multiply by cosine of minus 0.7 pi divided by 2. Clear? Understand, my dear? Now you can see, my dear, here I am going to divide each and every term. Y which is equal to ym, I am going to keep this 2 as it is. My dear, 2 kx over 2, this becomes kx. Am I right? Am I right?
Yes.
Yes.
Likewise, minus 2 omega t over 2 becomes omega t. Likewise, here 0.7 divided by 2, this becomes plus 0.35. Am I right?
Yes.
Here you will get cosine of minus 0.35
35.
pi. Clear? Now everything is
Can I
multiplication.
Can
What, my
I
dear?
by calculator?
Yes, you can, but my dear, you should be very, very careful, because in this question, what we are going to find? We are going to find only the amplitude. We are going to find only the amplitude. If you are using the calculator, you will get all the information. So we are going to calculate only the amplitude from this equation. So please don't use the calculator in this stage, okay? Clear?
Okay, clear. Yes.
Okay, now you can see ym multiplied by 2 sine, this term multiplied by cosine. My dear, in trigonometric, cosine of some negative term gives positive term. Am I right or not?
Yes.
Yes.
Cosine of negative is positive because we have the rule in trigonometric. So, my dear, listen carefully. I am going to take these 2 outside. So, what you will get? Y which is equal to 2ym. Cosine of this term is positive. Am I right? So, cosine of 0.35 pi, and then I am going to write this term as sine of kx minus omega t plus 0.35 pi. Clear? Clear?
I didn't get this
Yes.
information, Doctor.
My dear, here this multiply by this, multiply by this, because everywhere we have the multiplication sign. Am I right or not?
Yeah, but why cosine?
Minus, my dear, that is a rule. That is a rule in trigonometry. Cosine of any negative term gives you cosine of positive. Both are correct.
Oh, okay.
Cosine of any negative gives you the positive. This is the rule in trigonometry.
Okay, got it.
That's what I write positive term. My dear, listen carefully. We are going to find only the amplitude. My dear, listen carefully. Can you please recall the wave equation? Can you please recall the wave equation? Y, which is equal to Ym
Sine
of kx
kx
minus omega t some term. Am I right? Now you can compare this equation. This is my y. What is my amplitude? My amplitude is this. Am I right? Am I right?
Again,
Yes.
Mr.
And then my sine term is this. So in this question, they need only the amplitude. So I have to use the calculator to multiply. My dear, when you are about to calculate the amplitude by using the calculator, you have to use only in the radian mode. If you are using the degree mode, your answer will be different. Clear?
Yes, clear.
So my amplitude, the resultant amplitude, when you are just using 2 multiplied by cosine of 0.35 pi, gives you the value of 0.9. This will be the answer. This will be your resultant amplitude, because they need only the amplitude information. So what is our amplitude? Our amplitude is 2 multiplied by cosine of 0.35 pi multiplied by Ym is the amplitude of the resultant wave. Because when you mix two waves to each other, what is your resultant amplitude? Your resultant amplitude will give some value. But when you are about to use the calculator, you have to use the calculator in the radian mode. Please don't use the degree mode. If you are using the degree mode, then your answer will be different. Clear?
It's radian now, right?
It should be in radian.
Yeah, okay.
Clear? My dear, don't get squeeze your, it's my kind advice to each and everyone here. Don't squeeze your brain. These type of problem we will never ask in the exam, because this question is just to understand the theoretical information. That's what we are giving this formula for the student. Clear?
Okay.
So out of these 5 problems, you can just give importance only for the 4 problems. This problem is just to get some idea. Yes, my dear, ask your question.
Doctor, are you gonna upload the record now?
My dear, I already recorded this video, so you can take this video at any time.
Okay.
Clear? So thank you so much, my dear brothers. I think we finished the chapter.
Lecturer, I have question.
Yes, please ask your question.
The minus and cosine, where is gone?
My dear, cosine of any negative terms give. That's what I told you here.
Minus cosine, always observe.
My dear,
observe.
Cosine. Just a minute.
كوزين تبلع السالب.
Okay.
Cosine of minus a gives you the answer of cosine of plus a.
Okay.
Clear?
Clear. Excuse me, doctor.
Yes, yes.
Can you explain slowly, because you explain faster.
My dear, I'm just work out the problem step by step. I'm working I just work out this problem step by step. But now you are saying I'm taking very faster. What is this, my dear? Huh? Okay, you can just see here. We have 2 waves. Listen carefully. I will just explain one more time. We have 2 waves, and the first wave and the second wave both are moves in the same direction, but only one wave is moving out of phase. That value is given as 0.75 value. Okay, now we know the wave equation, so I write the first wave equation for the red color wave, and I write the second wave equation for the green color wave. Now we are going to find the resultant wave. So how you can find the resultant wave? By adding these 2 wave equation. So when you add, you will get this term. When you add, you will get this term. Because why I take this Ym outside? Because in first equation and second equation we have the Ym term, so I take this Ym as common term. So when you just add the remaining term, your equation will be like this. Clear? Now what I am going to do for calculating the amplitude, when you are using this sine function, that means the trigonometric formula equation, it will be very easy to get the final answer. So what formula I used here? I used sine A plus sine B, which is equal to 2 sine a plus b over 2 cosine of a minus b over 2. This is the rule. This is the rule in the trigonometric. So I am going to use this rule here. Now, if you just see here, I have sine of kx minus omega t. So this kx minus omega t, I am going to take as a term a, and likewise here kx minus omega t plus 0.75 as my b term. Now you can see this term is exactly similar like this formula. So I can directly apply this formula here. So what is given here? 2. So I just write 2 sine of a plus b. So what is my a term? This is my a term, and I'm going to add this a term with b term. So I will get this term. Clear? And likewise cosine of a minus b. So I write the cosine. What is my a term? My a term is kx minus omega t minus of b term. That means minus multiplied by plus kx gives you minus kx. Likewise, minus multiplied by minus gives you plus, and then minus multiplied by this gives you minus. So here I think this becomes, because both, I think this is minus. Oh no, this is correct. So we have to use here. So minus multiplied by kx minus multiplied by minus omega t gives you positive omega t. So you will get this term. So when you just see here, I have plus kx, I have plus kx. So this becomes 2kx. Likewise, minus omega t minus omega t. This is minus 2 omega t plus 0.75 divided by 2. But here in this term, plus kx minus kx get cancel each other. Likewise, minus omega t plus omega t get cancel each other. So only you will get minus of 0.75 over 2. Now, if you just see here, I'm going to use this 2 for each and every term. So I'm going to divide minus 2x divided by 2 minus 2 omega t divided by 2 plus 0.75 divided by 2. So when you do like this, you will get the term like this. And here cosine of negative terms, you will get the positive term. Now they need only the amplitude. So what I did, I'm just writing this equation. I compare this equation with my general wave equation. When you just see the general wave equation, we have the sine term, and then the remaining term is my amplitude. The remaining term is my amplitude. When you just multiply these with the cosine of positive 0.35 pi, you will get the amplitude value. So you have to use only the radian mode. Clear?
Doctor, thanks.
So my dear, listen carefully. Chapter 1 is, that means chapter 16 is over now. Now please, during the weekend, try to take a paper, solve this question by yourself. If you have any doubts, please, during the lab time, if you are in my lab section, you can ask. Inshallah, by next week, I will inform you. I will announce my office hour. So this time my office hour will be in the daytime, not in the evening time. So inshallah, I will tell you about my office hour. During that office hour, you can come and ask your doubts. I am here to help you.
Thank you so much.
Thank you very much.
Clear, my dear? So please, it's my kind advice. Don't waste your time, my dear. Every week, if you prepare the concerned chapter, that will be easy for your final midterm exam as well as the final theory exam. So please try to follow my instruction. This is my advice for each and everyone here.
When you will upload the slides, the doctor?
By my dear, today or tomorrow I will upload. Okay.
Okay, thank you.
I will upload. Don't worry. During the weekend, your slides will be in your hand. And also, your second chapter slides will be there. Your second chapter slides will be there. Okay.
No, okay. Thank you.
Okay, brother. See you, inshallah. Thank you so much for consider this time for my makeup class. Thank you so much. Your presence is really very happy for me.
Thank you too.